In reference problem number 5, we have the EPA gas mileage ratings for 100 vehicles, and they're given in this graph below. So the first thing we want to find out is what type of graph is employed. You'll notice that there are bars, but it is not a bar graph because bar graphs would have spaces in between each of the bars, and here we have intervals that are being used. So the use of the intervals is a clue that this is going to be a histogram. So for part A, we have a histogram. For part B, we're going to write the frequency above each class. That means go back to the first bar and look at the scale here on the left, and this is frequency, as it tells us frequency for the label. And since this bar is not quite up to the level 2, it looks about halfway. I would say it's 1. So the first two bars are a frequency of 1. The next one is 4. And then we have 2 at a frequency of 6. Again, we're halfway between 10 and 12, so that would be 11. The next bar goes up to 20, and then one level higher, 21. Our next bar would be 10. Next bar is at 8, and then 7. And let's see, this one looks like 3. This bar is 1. We don't have any bar here, so you don't need to write 0. And the last bar is a frequency of 1. Now if we go back to this description for problem 5, it says there are 100 vehicles given in the graph below. So if you add up all of the frequencies that we just labeled, you should have a total of 100. Now you won't always have 100, so it's good to either look at the description to see what's given or simply add up all of the frequencies based on the histogram. Alright, so part B, we have that done. Let's see. Part C, how many vehicles have an estimated miles per gallon between 36 and 40 miles per gallon? So I'm going to look at this horizontal axis for miles per gallon, find 36, and make a boundary there. That's the lower boundary. The upper boundary would be 40 miles per gallon. There's 40 miles per gallon. So I'll make a boundary mark here. So in between these boundaries would be 36 to 40 miles per gallon. So to answer the question, how many, that means frequency. So all we need to do is add up 20 plus 21 plus 10 plus 8. And that would tell us our frequency. So that looks like 41 added to 18. So that's going to be 59. Part D. This time it's asking for what relative frequency. So to find relative frequency, we would take our frequency and divide by the total number of measurements. And our total number of measurements would be the 100 vehicles. So first, let's find the frequency of vehicles that have an estimated miles per gallon between 36 and 40. Well, that was the previous question. So we know that was 59 for the frequency, but then we need to divide that by 100 to get the relative frequency. So 59 divided by 100 would be 0.59. That's the relative frequency. Notice that relative frequency is in decimal form. We also could call this probability, but we'll talk about that later in Chapter 3. Part E, What relative frequency of vehicles have an estimated miles per gallon of 40 or more? So this time we again are identifying 40 or more. So including 40 and higher. So that would be from 40 to the end. Those numbers would be 7 plus 3 plus 1 plus 1. So 7 plus 3 is 10. 2 more makes 12. So 12 is the frequency, but it's asking for relative frequency. So now I need to take 12, divide by the total of 100 vehicles to get 0.12 is the relative frequency. So 0.12 is our final answer. In part F, we're going to use the graph to determine the shape of the distribution. Now you can see that it starts off kind of low, rises to a peak, and then falls back down. So that's what we call the mound shape. Now we will be more specific about that mound shape in a later section. We'll determine whether it is symmetric or skewed left or skewed right, but at this point we just want to see that it is a mound shape. And our final question for part G wants us to calculate the class width. The class width is the difference between the lower limit of the first two classes, or really any two classes could be chosen. So our first bar goes from 30 to 31. So if I wrote that down as an interval, it would look like this, 30-31. Our second bar goes from 31 to 32. So the lower limits would be the first numbers in those intervals. So I would start with the higher number, subtract the lower number, and that would give us 1 for the class width. So you'll have more practice with this concept on the worksheet. I hope you found this helpful.